Hi class, we are now on 3.11, 3.12. These are the last two sections in this chapter, and this is going to build upon the temperature changes, heat capacity, so basically heat, energy, and temperature changes. So there's that Q that I had in a different section. It's called heat capacity. The quantity of heat, so the measurement of heat, usually in joules, required to change the temperature of a given amount of a substance by 1 degree Celsius or Kelvin. What that means is how much heat does it take to change the temperature of a certain amount of a mass by 1 degree of Celsius. When the amount of the substance is expressed in grams, the heat capacity is then called the specific heat capacity, and different books use different abbreviations. It could either be C, SH, or sometimes they even refer to it as just specific heat. So I'm giving you all of those so you understand. Has units of joules per gram per Celsius. So this one has 3 units: joules per gram per Celsius, or joules per gram Kelvin. Q has units of joules or calorie because this is the heat energy. Specific heat capacities is a fingerprint for different materials. So specific heat is a fingerprint because every substances have different specific heat capacities, and that is the value of how much heat goes in to raise the temperature of that substance. So here's a picture. You have 1 kilogram of gold and 1 kilogram of water. Water takes about 30 times longer to heat than gold, meaning it stores 30 times more calories, yet if you look at the thermometer, it barely raises in temperature. That's because it has a very high specific heat capacity compared to gold. Gold will heat up very quickly, and that heat will be transferred off very quickly. That's why we cook with metals. It transfers heat very quickly. You don't want to cook with something that's going to take 6 hours to transfer the heat to your food. So what do the values for specific heat mean? Okay, so substances with high specific heat values resist temperature changes more than substances with lower. Perfect example of going to the beach. If you're walking on the sand will get very hot very quickly. Yet when you get to the ocean water, it's very cold. Those are two different specific heat values. Water takes a lot of energy to heat up even a little bit. On a hot day, you jump into a cold pool. Yet sand is bearing, the sun's bearing down on that same sand, which is next to the cold water, and it's very hot. It transfers heat a lot quicker than, and doesn't hold heat as much as water can. So substances with high specific heat values also retain the heat energy longer, and it also means it takes longer for that to cool down, releases the heat slowly. So oceans, communities by the beach, excuse me, I'm losing my train of thought. Communities by the beach, the ocean during the day helps retain the energy and doesn't release it. So the ocean, that's communities by the beach, tend to be cooler, but yet at night they actually don't get very cold because that's when the ocean starts releasing that energy off, the heat off. If you were to go more inland, parallel to where a beach community is, it would get colder and colder because you're away from the water. The water is there to shield it, but as you keep going in, the temperatures will go very, very cold compared to what a community is at the beach because it doesn't have the water to help with the temperature. So dry sand on the beach can be uncomfortable to walk on, and that is because it has a low specific heat value of 0.239 calories per gram per Celsius compared to water, which is 4.184 joules per gram per Celsius. So here is a chart of specific heat values in joules and calories per gram per Celsius, and you can see I've highlighted water, and you can see it's very high in comparison to other substances on here. You can even see that strawberries have a high specific heat value. Wax, glass, brick, cheddar cheese. Don't say scientists don't research everything. Gold, chromium, calcium, they research, but you see how these numbers are very low compared to something like water. Water as a solid, water as a liquid, water as a gas, asphalt, so forth. So you can see water has a high specific value. So what does that mean? If you have a low specific heat value, then it's going to be easy to warm up because there's an easier transfer of heat from the substance. But if it has a high specific heat value, that means it's going to be harder to warm up because it's going to hold on to that energy, because it's going to take more and more energy in order to raise that temperature. So now we're going to start getting into equations. So specific heat capacity has 3 units to it, and it this is Q, which will be joules or cals. Mass is grams. And then the temperature difference is Celsius or Kelvin. So Q, heat of reaction, joules or calories. M is the mass of the substance. C is specific heat. And the temperature change that will be given. So if you are looking at Q, Q alone is 1 unit. But if you're looking at specific heat capacity, that is 3 units. It's either joules or cals, grams per Celsius. But if you wanted the heat, the amount of heat that needs to be involved in order to change the temperature, that is Q. So you will rearrange this equation to this. And then you will have mass, which is the mass of the substance, the specific heat capacity, and the temperature change. All of these three will cancel out, leaving joules or cals. And this delta T, this means temperature change. When you see a temperature, when you see a triangle, that means change in whatever it is. So relating heat energy to temperature changes. Gallium is a solid at 25.0 degrees Celsius and melts at 29.9 degrees Celsius. If you hold gallium in your hand, it can melt from your body heat. How much heat must 2.5 grams of gallium absorb from your hand to raise its temperature from 25 to 29.9 degrees Celsius? You're also given the specific heat of gallium. So first we need to break this problem down. So you have to take your time and learn how to read a chemistry problem. It's a different language, and for some students, most students, the minute you start reading a problem, you panic, thinking that you are not capable of doing the problem, and you absolutely are, and you can be your own worst enemy and not get out of your way in order to read the problem. Because what will happen is that once you see the answer, you will see that it's not as difficult as you thought it was, and you probably knew how to do it the whole time. So first things, get out of blocking your thinking by saying that you cannot do something. The panic will always hurt you from figuring out stuff when you're very capable of doing it. Okay, so let's look at this. How much heat? Right there, those three words are telling you exactly what you need, what is asking in this question. This question is asking for heat. What is the measurement of heat? It is Q. Q is what it wants for this. Okay, so this is asking for Q. Q is 1 unit, meaning that your answer has to be either in cals or joules. So you have to know which equation that you've got to use. So you're going to use this bottom one here. That's heat, quantity here, heat capacity. How also is this a good indication? Well, you're given a mass, which is right here. You're given a temperature difference, and you're given the specific heat capacity. So you have everything you need, and now you just have to plug this in. So one of the things I want to point out, temperature difference is always final minus initial also. So here is C. C is your specific heat. M is your mass. Temperature difference, 29.9 minus 25 equals 4.9 degrees Celsius. Plug it all in. You have 2 sig figs here. Your answer is going to be in 2 sig figs. See where it's rounded? That is the amount of heat required to raise the temperature to the melting point. All right, let's do another one. Okay, so now calculate the specific heat of water. So the other one was looking at the heat capacity, how much heat it takes to raise a temperature of a certain substance. Now we're going to look at the actual specific heat. This is going to require 3 units. Calculate the specific heat of water. If 83.68 joules is required to raise the temperature of 4 grams of water by 5 degrees Celsius. Those are a lot of zeros there. This is crazy. Now, pay attention to what it's asking. It's asking first, it tells you flat out in the first 4 words, specific heat of water. Well, that's more than 4 words, but specific heat of water. So that means 3 units. You have joules. Look at units. Units will always help you. This is a Q because it only has 1 unit into joules. This is your mass. This is a temperature. So let's take a look at what we need here. We have Q equals MC delta T. Now we're going to rearrange it to this. This is what we wanted as. So Q is right here. Mass is here. And you don't even have to do any subtraction for the temperature. It's already given it to you. So you plug it in. And everything here is 4 sig figs, even though it looks crazy. And your answer is 4.184 joules grams per Celsius. So C should have 3 units, 1, 2, 3 for specific heat, and it does.